Yeah. Hi everyone. So I think in this today's session, we will discuss about the remaining features, guys. Okay. So today we will discuss the other feature called multi-threaded. Multi-threaded. Right. Java is a multi-threaded, guys. Okay. Right. Now, what is multi-threaded? Okay. So now you see, we have a one work. Okay. We have a one work. To complete that work, okay, for one person, that it takes 10 days. Okay, for one person to take a particular task, it may take, let's assume, take 10 days time, right? So now in the same work, if you assign to two persons, definitely it can be completed with less time, right? Can be completed with less time, guys. Okay, less time it can complete either, right? Either 5 days or 6 days. Okay, comparatively 10 days, within less time it can complete, right? So why here two persons are working parallelly, so then the time also within less time we can complete that particular work, right? Now we can apply same thing to here. Okay, now let's come to Java program, guys. Okay, so if you take a Java program, okay, so this is kind of one Java program. Okay, so here these are what, guys, all the lines of code. These are what, all the lines of code. Okay, these are what, all the lines of code. Okay, these are what, all lines of code. Now in Java, okay, in Java, the the program executes line by line, guys. The JVM, okay, it executes line by line. So always in Java, so how it will be executed line by line. Line by line means sequential program execution will be taken care, will be takes place by in Java, right? So JVM will execute sequentially one by line, right? Sequential. So by default, JVM will execute what? Sequential program execution, right? Sequential program execution, okay, will be performed by whom? JVM. Now, if you see here, let's suppose here that these are the programming code, right? So let's suppose we have a 10,000 lines of code. Total how much it is? 10,000 lines of code, guys. Okay, 10,000 lines of code. Now, the first 5,000 lines of code, and the second 5,000 lines of code. Let's assume these are first 5,000 lines of code. These are what? First 5,000 lines of code. So these are what? Another 5,000 lines of code. Okay. Yeah. First 5,000 lines of code. These are another 5,000 lines of code. Now, so why we are, I mean, JVM here executing line by line, guys? Okay, why JVM executing the program line by line? Let's suppose the first line of execution. Okay, so once the first line of executed, it will give some result, right? After execution of line, you will get some result. Maybe that result can be input to execute of second line of code. Understand? So let's suppose after executing the first 3 lines of code, you will get some result, right? Maybe that result, okay, will be useful as an input to execute the next fourth or fifth line of code. Okay, so that's what by default JVM will execute all lines of our program one by one sequentially. Right. Now, if you see in this program, first 5,000 lines of code and the second 5,000 lines of code are completely independent. Means what? First 5,000 lines of code, after completion of this 5,000 lines of code, what is the output we are getting, right? So we are not using that output as an input to next 5,000 lines of code execution. Understand? So here what I mean to say, the first 5,000 lines of code and another 5,000 lines of code completely independent to each other. So if both are independent to each other, why I should do wait? Why the last 5,000 lines of code? Okay, so last 5,000 lines of code has to be wait until the first 5,000 lines of code completion, right? So we no need to wait. Right. So here what the first 5,000 lines of code and last 5,000 lines of code what completely independent to each other. Then the last 5,000 lines of code execution need not to wait until the first 5,000 lines of code execution. Clear? Now, instead of executing total 10,000 lines of code one by one, why can't we execute first 5,000 lines of code and another 5,000 lines of code, okay, parallelly, because these are independent to each other. Understand? Because these are what? Independent to each other. I mean what? First 5,000 lines of code, okay, this is one flow of execution. Next 5,000 lines of code, this is another flow of execution. Okay. Hmm. First 5,000 lines of code. Okay. This is one flow of execution. And here the second 5,000 lines of code. The code is what? Another flow of execution. Right? So if you execute first 5,000 lines of code and another 5,000 lines of code parallelly, then we can complete, okay, this program, okay, we can execute this program within less time, right? So if you make this I mean in the first 5,000 lines of code and second 5,000 lines of code independently and parallelly, then we can achieve here what? Okay, performance, right? Performance of the application also will be improved, right? Okay, so this is what guys, parallel execution. This is what? Parallel execution. Parallel execution. Okay, so this is what parallel execution, guys. Something is happening. Okay, so this is what, guys, parallel execution. Yeah. Here what? First 5,000 lines. This is one flow of execution. This is another flow of execution. Okay. This is what? First 5,000 lines of code, right? Hmm. This is what, guys? Another 5,000 lines of code. So if we execute these first 5,000 lines of code is for first flow of execution, the second 5,000 lines of code for second flow of execution, then we can achieve what is parallel par parallel programming execution. Okay, parallel program execution, right? Okay. Now here each flow of execution is called thread, guys. Here each flow of execution we used to call as what? Thread, guys. Okay, this one thread, this one thread. Okay, so here what the same program. Okay, so we are executing, okay, two different independent parts of the same program. Okay, we are executing two different independent parts of the same program parallelly. Okay, then we can achieve what performance of the application, right? Let's suppose if for 10,000 lines of code, if we follow the sequential program execution, let's suppose if it is taking, okay, 10 minutes of time, let's assume. Then if you make each 5,000 lines of code is for one flow of execution, and the second 5,000 lines of code is another flow of execution, then within less time, okay, we can complete this program execution, right? So here what we can achieve? We can achieve performance, right? Here, each flow of execution is called as one thread, right? Here, multiple threads are what? Executing parallelly, okay, to complete the program. Here, first 5,000 lines of code is one thread, I mean one flow of execution. Second 5,000 lines of code is another flow of execution. The first thread, okay, will responsible to execute this first 1,000 lines of code. Second thread is responsible to execute the next 5,000 lines of code. Now, two threads are executing parallelly to complete this program, okay, to execute this program, okay. Then, of course, okay, within less time, we can complete this program execution. Understand? So now, so here, so this is what multi-threaded, guys. Okay, multi-thread. This is high level. Okay, we will see so in detail internal concepts of multi-threading. Okay, so here, so to support this multi-thread, okay, to support this multi-thread, the Java people, I mean, as part of JSC module, we have a rich library, guys. Okay, multi-thread library. So we have thread, thread class, runnable interface, and callable interface. Like that, we have predefined classes and interfaces as part of multi-thread, okay, multi-thread, okay, Java library. By using these classes and these predefined interfaces, okay, we will write a code, okay, we will write a code, okay, to execute two independent parts of the same program parallelly. Okay, as a programmer, we have to write the code to execute to independent parts of the same program parallelly, guys. Understand? So JVM will not execute, okay, to independent parts of the same program parallelly, guys. Okay, JVM always executes each line of the code sequentially. Okay, so for JVM, don't know anything about parallel execution. So in order to achieve parallel execution, as a Java programmer, we have to write, okay, the code explicitly by using multi-threaded, okay, APIs, multi-threaded libraries like thread class, runnable interface, callable interface. Like that, we have so many classes and interfaces. So by using those classes and predefined classes and interface, as a programmer, we need to write the, okay, so code, okay, in order to execute these two independent parts of the same program parallelly. Understand? So then only, okay, we can achieve this parallel execution. Understand? Due to this multi-threading feature, JVM will not execute this, okay, two independent parts of the same Java application, okay, parallelly, guys. Okay. So by using those libraries as a programmer, we have to write the code. Okay. We have to write the code, okay, to execute two independent parts of the same program parallelly. Understand? So we have to create a thread and we need to assign first 5,000 lines of code to that particular thread. And after that, again, as a programmer, we have to use some three different classes and libraries which are provided by multi-threading. By using those classes, we have to create another thread. Okay. So that thread, the next 5,000 lines of code, okay, will be will be assigned to another thread. So another thread will execute the remaining 5,000 lines of code. Okay. So this is what is multi-threading at a high level. Okay. In the case of multi-threading, what multiple threads can run simultaneously and can perform what specified tasks simultaneously. So that performance of the application will be improved. Okay. So yeah, hope you people understand what is multi-threading concept very high level. Okay. So this is the what, okay, one of the feature of, okay, Java, guys. Now, so let me write one point here. In the case of multi-threading, right, multiple threads can run, okay, simultaneously and can perform and perform the specified task simultaneously. Okay, so that what will happen? Performance of the application will be improved, guys. Application will be improved. Okay, now Java provides inbuilt support for, okay, multi-threading. Multi-threading by providing what? By providing, okay, rich API. Okay, rich multi-threading API. Okay, by default, okay, Java will not support okay, will not support what? Parallel program execution. Okay. So it provides hmm, multi-threading libraries. Okay. By using these libraries, okay, programmer has to write the logic or code. Okay. Logic or code for what? Parallel execution. Code for parallel execution. Clear? Right. parallel execution, right? So this is what, guys, multi-threading, guys. Okay, multi-threading feature. Yeah. Now we will go for next feature. What is the next feature, guys? After multi-threading, robust. It one we got robust. Yeah. What is the robust? Okay. Java is a robust language. If you see the name, okay, the word called robust. Robust is what, guys? Okay. So very strong. Okay. The meaning itself is a very strong, right? Now, so why robust? Okay, Java is a robust. Okay. So the chance of failure Java application at runtime is very less, guys. Okay, the chance of failing Java application at runtime is very, very less. So why? Okay, so Java is a, first of all, okay, Java is a what, guys? Java is a strongly typed language. Strongly typed language. So why we use it to call Java is a strongly typed language, guys? Okay. So in Java, we have a compiler. Okay. So each and every variable declaration and assignment, okay, will be checked by the compiler. Okay. Strongly checked by the compiler. Each and every variable declaration, each and every assignment, okay, will be checked by the compiler, okay, for type compatibility. Okay, strongly checked by the compiler for what? Type compatibility. Means what? All the type compatibility related issues where we are going to solve at the compile time itself. Now, so once we resolve all these issues, all these type related issues at compile time, then obviously, okay, at runtime, the program execution will be smooth, right? The program execution will be smooth because what? All the type related issues where we are founding at the compile time only we are founding. Okay. Once you found means what? Okay. At compile time only we will fix those all the type related issues so that obviously, okay, at runtime program execution will be smooth. The chance of failing Java program at runtime is what? Very, very less. Due to what? Okay, this strongly typed language. Okay, due to this compiler. Clear? Now, so Java is what? Strongly typed language. So here we will write. Compiler, compiler will check hmm, each, hmm, each and every, hmm, each and every declaration and assignments at compile time only, right? At compile time only for what? For type compatibility. For type compatibility. Okay. For type compatibility. Okay. If any problem with respect to types, at the compile time only we can identify the problem, right? So that any problem with respect to type, we can identify at compile time only. Okay, at compile time only, right? So that okay, the Java program execution, okay, at runtime will be smooth, right? Now, now, so this is the one. I mean, due to this type compatibility, you can say Java program is a robust. Yeah. Then the other one. So in Java, we have a garbage collector feature, guys. So what garbage collector will do? Okay. If any inactive objects are available, then garbage collector automatically, okay, deletes those inactive objects, okay, for memory management. Okay, guys. So Java means what? We will write lot of classes, right? So for the class means we will create objects. So somehow, sometimes, okay, we will create objects, but after some time, those objects are what? Inactive objects. Okay, not useful objects. If any unuseful objects are available or inactive objects are available, then garbage collector immediately, okay, it will delete all the inactive objects and it will clean all the inactive and unuseful objects. So that what, okay, memory will be, okay. So here memory management, okay, will be taken care by whom? Garbage collector, guys. Understand? So due to this, okay, so you can say with respect to memory, okay, the Java program, okay, the failing of Java program at runtime is what? Very, very less. Okay, due to this garbage collector, garbage collector, okay, will remove all inactive, okay, inactive, okay, inactive objects, okay, inactive attributes, okay, to increase memory, to increase memory or memory management, right? So due to this, okay, with respect to memory, okay, chance of hmm, chance of failing Java program at runtime is very less. Understand? So due to garbage collector, right? So Java provides what? Garbage collector for what? Automatic memory management, guys. So as there is no chance of memory related issues. Understand? There is no chance of memory management, memory related issues, guys, at runtime. Come on. Okay. So what is the use of this garbage collector? This garbage collector is what? Built-in feature in Java, guys. Okay. So automatically garbage, when the inactive objects are available, automatically garbage collector will active and will remove those inactive objects. Okay, will clean all the inactive objects. So that what memory will be increased, right? So then you can, I mean, garbage collector will manage what? Memory management. So due to this, right, with respect to memory, okay, with respect to memory, chance of failing Java program at runtime is what? Very, very less. Okay. With respect to memory, chance of failing Java program at runtime is what? Very less. Okay. Now we have another concept, guys. Another beautiful concept called, okay, exception handling in Java, guys. Okay. So due to this exception handling also, the chance of failing Java program is very, very less at runtime. So what is the exception handling? Okay. So now let's suppose, let me take a one real world example. Okay. Now, so you went to Tirumala. After darshan, again, okay, you will come back to Hyderabad. Okay. Wanted to come back to Hyderabad. So at evening, you have to attend one important function at Hyderabad, right? So at any cost, you have to come. So morning, okay, at 6 o'clock, at 7 a.m. or 8 a.m., okay, you started from, okay, Tirumala. Okay. So you have taken one Innova car and you are coming. Okay, you're coming back to home, Hyderabad. At the Kurnool, okay, at Kurnool, so somehow unexpectedly, so there is a problem at your car. At the engine side, there is a problem, right? So what we have to do? So by that time, okay, so at Kurnool, okay, so there is a problem in your car. The engine side, there is a problem. So what you have to do? Okay, so you have to keep your car side, right? So after that, we have to choose another car because what this is important function. So at any cost, you have to attend that function, okay, at evening. So alternatively, you will choose some other option. So here what you will book one more car, okay, in the nearest travel agent, okay, you will book one more car, and by using that car, okay, you will come to Hyderabad, right? Here, so that event is what is something in the at Kurnool, okay, you faced some issue that is unexpected, okay, that is unwanted event, right? Now, if the event is occurred, okay, so now you are choosing other alternate, okay, alternate way, and you are coming to Hyderabad, right? Now, finally, you reach to what? Hyderabad. This is what is graceful termination. This is what graceful termination. We can apply same to what program. Okay, we can apply same to what program. So in the programming, let's suppose we have a one Java program. In the Java program, let's suppose we have a 5,000 lines of code. Okay, so first 2000 lines of code execution completely successfully completed. That after 2000, so after 2000, there is a problem at the 2001 line of code. Okay, so there is a issue. There is a runtime issue. So if you are not handled that exception, okay, if you not that handle that issue properly, then your program will be terminated abnormally, right? Your program will be terminated abnormally, and you will see, okay, all the errors where in the console, okay, you will see all the errors, okay. Those errors, what guys, it's completely technical related issues, related errors. Okay, if you see those errors, if you as a technical person, you can understand. But if any layman, yours always client is what is layman. He don't know anything about technology. Okay, if he see the errors, what he will think, right? So I don't know. So the program is, I mean, they did not implement properly. Like that client will feel, right? So this is what guys abnormal termination. Okay, so always, okay, so always program should terminate, okay, gracefully, guys, normally, okay. Any program should not be terminated abnormally, okay. So now, so in that case, right now there is issue at line number 2001. Okay, now to solve that issue, okay, we need to use exception handling. So we have a exception handling mechanism in Java, right? So we are using to handle that exception. There is a try, catch, and finally, right? So these are the reserved words we have, guys. Okay, keywords we have. So by using these, we can handle that exception. Okay. So all the exception related code. Okay. So if you think these lines of code may raise an exception. Okay. If you think like that, we will keep those lines of code under try block. Okay. Now, immediately after try, there is a catch block. In the catch block, if any exception is raised in the above lines of code, in the catch block, okay, we will handle that exception. Understand? We will handle that exception. So finally, what that catch block will executed and remaining program will be executed normally. And finally, you will see what normal termination. That means what graceful termination. Understand? So here we will not see any abnormal termination. Finally, we will see what is graceful termination. Understand? So with respect to exception handling also, okay, with respect to exception handling also, okay, Java application will not fail at runtime. The failing of Java application at runtime is very, very less, guys. Okay, very, very less. Hmm. So we have a okay exception handling mechanism in we have an exception handling mechanism in Java. Okay, mechanism in Java. So by with respect to Java. So if we have any exceptions raised at runtime, we can handle those exceptions by using try, catch, and finally. Okay, finally blocks. Okay, finally blocks. Okay, finally blocks. Okay, we have an exception handling mechanism in Java. If we have any exception raised at runtime, we can handle those exceptions by using try, catch, and finally blocks. Okay, for what? For graceful termination. For what? Graceful termination of the program. Okay, with respect to, okay, with respect to exception handling, okay, failing of Java program at runtime, okay, the chance of failing Java program, guys. The chance of failing Java program at runtime is what? Very less. So, due to all these features, due to strongly typed language, due to this garbage collector feature, due to this exception handling mechanism in Java, okay, we can say our Java program is robust. Clear, everyone? So we will see, guys, what is garbage collector, okay? So what is exception handling, okay? We will see in details, okay? We have a concepts, right? Core Java concepts. There is a garbage collector concept we have, and there is exception handling concept also we have, okay? So there we will see in detail, right? So this is what high level. So due to these features, we can say what Java is a robust, right? Hope you people clear, right? Now, the other features. We will discuss the next one, guys. What is the next one? Distributed. Java is a distributed. So I think already we discussed what is distributed application, okay, while discussing J2W module, right? So in the J2W module, already we discussed what is distributed application. Right. So, okay. So, yeah. So we'll see what is distributed. Let's suppose in the layman, okay, let's suppose you opened one biryani point, guys. Okay, where you open, let's suppose in Hyderabad, at Secunderabad, you open one biryani point. Okay, so within few days, okay, the biryani point is what? So they're popular. Within few days, it got popular, guys. So many customers within Twin Cities. Okay, most of the customers are coming. So now, if you have only one outlet, one biryani point, you cannot serve. Okay, the huge crowd, right? We cannot serve huge crowd. So we will face lot of traffic issues and all. Right. So now what we are doing, okay, by using one outlet, we are not able to serve huge number of people. So we decided to put, okay, two more outlets. One is at high-tech city, another one at like Kokatpalli or somewhere. So, so if you put these three outlets, we can reduce, right? So the number of customers coming to Secunderabad can be reduced, right? What few customers will move to high-tech city, Okay, the customers which are near to high-tech city, all those customers will go to home high-tech city branch, right? And the Kokatpalli, Miyapur, okay, Pragati Nagar, all these areas people will go to home, okay, the Kokatpalli branch, okay. I mean, these people will go there and they will okay, buy biryani over there. Okay. So now see here, here the same biryani, right? The same flavor, the same taste. Okay. But here what instead of one branch, now we are keeping three branches, right? So we are distributing what? Okay. We are distributing same biryani into now three, three outlets, okay, three branches. So now, if you put like this, what will happen? You can route the traffic. We can route the traffic, okay. Instead of one branch, we can switch or we can route the traffic to three different branches, right? Three different branches, right? So the same thing, guys. You can apply the same thing to here distributed application. Okay. Now you developed one application, guys. Okay. So already we discussed, I think. Okay. So we developed one application like e-commerce application, Amazon application, right? The Amazon application where we deployed in finally one machine, right? So this is what, okay, machine. Let's suppose this is what machine one. Okay. In the machine one, we deployed an e-commerce application called, let's suppose, Amazon app. Okay, Amazon app. This is what e-commerce application. Now, this Amazon guy, okay, at the time of big billion days, okay, he will put lot of offers. So that time what? Hmm, most of the customers are what? Due to these offers, most of the customers, okay, will try to purchase some products from Amazon website. So that time obviously you will see what huge crowd, huge traffic, huge requests. Okay, now if you deploy this Amazon application into one server, okay, it cannot handle okay huge number of requests. Okay, so okay let's suppose it can handle only 5,000 requests at a time, right? So now at the same time if another 5,000 requests are came, right, it cannot handle, right? Let's suppose this is the right. These are what clients. Okay. So from this client, let's suppose 5,000 requests are coming. And from this client, let's suppose 5,000 requests are coming. Okay. So now we can say this is one city, this is one city. Let's suppose this is a Hyderabad city. From Hyderabad city, okay, 5,000 requests are coming. Okay. 5,000 users are trying to okay purchase something from Amazon app, okay, on the same day. Here from Mumbai city also, okay, this is Mumbai city, this is what Hyderabad city, right? Hyderabad city. From the Hyderabad city, let's suppose 5,000 customers are there. So those 5,000 customers, they open their own laptops, okay, and they open this Amazon app, okay. So now they started sending requests, okay, to buy something. From the same way in the Mumbai city also, 5,000 customers, they are trying to something, okay, they're trying to buy something from Amazon application at that day. Now, this Amazon application can able to okay process at a time 5,000 requests. Now at the same time if another 5,000 requests are came, okay, it's not able to process all the requests at a time. Now it may get chance to what, okay, it may crash the application, guys. There is a chance to crash the application, right? So if the crash the application means what, okay, you know what will happen. Okay, so now, see, actually, what instead of that, what we are doing, we are okay. Hmm, we are How to resolve this issue? Instead of one machine, we will deploy same application, okay? Same application into what? Some parallel machines case, right? Like the same parallel machines. So here also what? Imagine application. Okay, here also Amazon application, and here also Amazon application. The same application, right? The same application we will deploy into home. Okay, three different server machines. This is also one machine. Okay, this is, let's suppose, machine 2. This is what, guys? Machine 3. Machine 3, right? So one machine cannot serve all the requests at a time. So that's what same Amazon application. Now we are deploying to whom? Another two parallel server machines. Now, first 5,000 requests, okay. Now for the first 5,000 requests, the machine one can take, okay. It can process the first 5,000 requests. Now, another 5,000 requests are this next 5,000 requests, okay. Now, we will route to home, okay, machine 3. Now, machine 3 will process this another 5,000 requests. Understand? 5,000 requests. If another 5,000 requests are came, those another 5,000 requests who will process, guys? Okay, the another machine, right? So let's suppose here also we have one more 5,000 requests. Okay, now who will take this another 5,000 request? Okay, the another machine, guys, machine 2. In the machine 2 also we deployed what? We hosted what? Same as Amazon application, right? So here the functionality of the applications, okay, we distributed what? Across the, come on, what we are doing? The functionality of the application is distributed across multiple machines. Such type of applications are what, guys? Distributed applications, right? Here what? The same functionality of the here also Amazon application, here also the same Amazon application, here also same Amazon application. Instead of one machine, we deployed into home three machines, guys. Now all these three machines ready to serve the, okay, ready to serve the services, ready to take the request and process the request and finally send the responses, guys. Now, how can, okay, how can this first server will take this 5,000 request? How the second 5,000 request will taken care will taken by the second machine and third machine, guys? Okay, how they can know? Okay, so there is a concept called load balancer, guys. There is a concept called load balancer. This is what, guys? Load balancer. Okay. Now, load balancer, what load balancer will do? This load balancer also one kind of software application, right? So in between, we have a load balancer. So now, load balancer first, let's suppose from Hyderabad city, okay, initially 5,000 requests are came. Now, load balancer will take all these 5,000 requests and search, okay, all the machines, okay, in which machine is idle and which machine is busy. Like that, it will verify. Okay, fine. The first machine is idle. All these, first of all, initially all three machines are idle, right? Now, load balancer, okay, will route these 5,000 requests to home, the machine one. Immediately at the same time, another 5,000 requests are came from Mumbai city. Now, load balancer will verify, okay, now the machine one is busy with the first 5,000 requests. Let's search with another machines. Yes, so another two machines are, okay, idle now. So let me route the another 5,000 requests to home, okay, machine 3. Understand? Now, the machine 3 will take all these 5,000 requests and it will process those 5,000 requests. Okay, at the same time, another 5,000 requests are came from, let's suppose, from California. So now all these 5,000 requests are, now load balancer will take and it will verify the already these two machines are okay busy with processing okay other requests. Let me route this traffic. Let me route this load to whom now? Machine 2. Now, machine 2 will take, all these 5,000 requests and will try to process those requests. Will try to process those requests. Understand, guys? So like this, okay? So we can process all the requests, guys, okay? So all these machines will be there in one cluster environment, guys, okay? We will see. So in detail, we will see while discussing about distributed applications, okay? While writing distributed application related programs. So that time, so we will discuss in detail. This is what high level. Now, so what is the distributed application means? Okay, so so the functionalities of the application distributed across multiple machines of the multiple machines. So such type of application is called what? Distributed application. Okay. So Java provides what, guys? Inbuilt support for this distributed application programming language. So by using what? RMI technology, EJP technology. Okay. So by using these technologies, okay, we can develop this distributed application. Okay. So I think already we discussed at the time of J2W module, guys. Right? J2W module already we discussed. So here in the distributed application, we can achieve this load balancer. By using this load balancer, we can achieve this distributed application, implementation, guys. Now, here failover situation, okay, we can achieve failover situation. What is the failover situation? Let's suppose the first, okay, the first machine, somehow there is an issue. The first machine has been crashed. So immediately the 5,000 requests, the requests which are processing by the machine 1, automatically it will route to whom? The other machines. We have other two machines, right? Backup machines. The two other machines will take those requests and will process. Understand? So here what? We can achieve what? Failover situation in the distributed application development. Understand? We can achieve failover situation in the distributed application development. Right? Somehow the first machine is crashed due to some issue. So remaining already two machines are active and running, right? Two backup machines, right? Those two machines will take the first 5,000 requests, and those process they can process those 5,000 requests. Okay, they can send the response back to those particular clients, right? So we can achieve what? This failover situation. This is what failover. So we can achieve this failover situations in distributed application development environment, right? Now, let me write few points, guys, here. I hope you people understand what is distributed application. If the application, if the functionality of software, if the functionality of the application distributed across the multiple parallel parallel server machines, parallel server machines, such type of applications are called what? Distributed applications. Okay, distributed applications. Okay, now so Java provides inbuilt support for developing distributed applications by using RMI, EJB, okay, RMI, EJB, FORPA, etc. technologies. Clear? Okay. Now, okay. So this is what, guys. Okay, distributed applications. By using load balancer, we can achieve distributed application development, okay, and failover situation also we can achieve, guys, in the distributed application development environment. Fine. Now, so this is all about distributed, guys. Okay, very high level. Now we will see the other feature. What are the other features, guys? We have, okay, the next 10th one. Java is compiled and interpreted. Java is what? Compiled and interpreted. This is the another feature, guys. Java is compiled and interpreted. Tell me, what is the Java is compiled and interpreted? So here, Java is both compiled and interpreted programming language. First, Java compiler compiles the Java code and generate machine-independent bytecode, right? At runtime, JVM interprets that bytecode into machine code and executes that bytecode, right? So here what we will do, compile Java is what, guys? Compiled and interpreted code, guys. Okay. So Java is not directly interpreted programming language. Let's suppose if you see Python. Python is what, guys? Interpreted programming language. Okay. But whereas Java is what? Compiled and interpreted programming language. Okay. So Java is what? Both compiled and interpreted programming language. First, what it will do, Java? First, it will compile the Java program, right? First of all, Java, what it will do? It will compile the Java program. So in the compilation itself, okay, it will verify all the syntactical related issues, okay, the type compatibility related issues. So all the issues at compile time only, okay. So compiler, okay, will take in care all these issues. To whom, for what? To smooth execution of the program at runtime, right? To smooth execution of the program at runtime, compiler will verify all the syntactical related issues and type compatibility related issues at compile time only. Okay. After compilation successfully, okay, after that what it will generate, guys? Compiler will generate one bytecode. Okay. Once compilation is successfully done, then compiler will generate one bytecode. Right. So the bytecode is what, guys? Platform independent bytecode, right? Platform independent bytecode, right? So now, so after that, what will happen? We are handovering this bytecode to whom? JVM, right? So in JVM, okay, in JVM, there is a concept called interpreter. Okay, this interpreter will read this bytecode, okay, line by line, and it will interpret and it will execute, guys. Okay, interpret means what? Here, interpret means converting. Okay, it will read that bytecode and it will convert into machine understandable code. I mean, the native machine understandable code, and after that, it will execute. Okay, so who will do these things? Interpreter will do. Okay, at runtime, this interpreter will interpret, okay, the bytecode into machine code, then executes that machine code, guys. So now, here what? Java is what? Compiled and interpreted programming language. Understand? So all the issues, so most of the issues where we solved at the compile time only we solved. Understand? So to reduce the burden at runtime, guys. Reduce the burden at runtime. So if you solve all the issues at compile time, then at runtime, the program will be executed very smooth, right? Come on, right? So that's why Java is what, guys? compiled and interpreted language. Okay. So you want me to write few lines of statements here? Okay. Java is both compiled and interpreted. Okay. Interpreted language. Right. So initially or first the Java compiler okay compiles the Java program or Java source code, right? Java program, okay, and finally it will generate bytecode. Bytecode means what? Will generate platform independent bytecode. Okay, any platform can execute that bytecode, right? So that's why it's about platform independent bytecode. Okay, so compiler okay will encounter okay most of the hmm, syntactical and semantical and type related okay, issues at compile time only to reduce burden on runtime or for smooth execution for smooth execution of the program at runtime. Okay, clear? So this is what compiler will take care all these things. Now interpreter. Okay. Now JVM will take the independent platform independent bytecode. JVM will take bytecode. Okay. Then okay. So there is a interpreter inside JVM, right? So now JVM will take this bytecode, okay, and it will interpret. It will interpret. Okay, it will interpret the bytecode. Interpret this bytecode into machine. Okay, machine understandable code. Understandable code means what, guys? Underlying operating system understandable code. Okay, and it will execute. Okay, it will execute that machine code, guys. Finally, it will convert to machine code, right? So that machine code will be executed by JVM. So internally, who will do this one? There is an interpreter, guys, inside the JVM. So there is an interpreter inside the JVM. Okay, it will taken care all these things, guys. Okay, so this interpretation logic, right? This interpretation part, who will taken care? Interpreter, which is part of what? JVM. So now you can say Java is what? Compiled and interpreted programming language, right? Why? To smooth execution of the program at runtime, at compile time only, okay, we will encounter all the issues, right? We will fix all the issues at compile time. so that our Java program will execute smoothly at runtime without any issues. Clear? Right? Now, so this is what, guys, okay, compiled and interpreted feature. Now, we will go to another feature. What is the another feature, guys? Okay, Java is high performance. Java is what? High performance. Java is high performance. Now, tell me, how Java is high performance language? Okay, now, see, now, so here, okay, now, so we have a Java program, right? So finally, who will compile that? Okay, valid Java compiler will compile the Java program. Finally, we will receive what, guys? Bytecode, right? So the bytecode who will take in care, who will, the JVM will take that bytecode, okay? It will start execution. How it will start execution, okay? Now, let's suppose in one Java class, okay? In a one Java class, let's suppose we have a one Java class, guys, okay? In the Java class, there is a method called M1. Let me write. This is the Java class. Let's assume in the Java class there is a method called, okay, M1 method M1, guys. This is the M1 method. Okay, there is a M1 method. So in this method we have a, okay, let's suppose 10,000 lines of code we have. How many? 10,000 lines of code we have, or 1 lakh lines of code we have, like this. There. So like this, we have a 10,000 lines of code or 1 lakh lines of code we have, right? This is one class, some class, guys. There is a class called test. In the class test, we have a method M1. In the M1 method, we have a 10,000 lines of code or 1 lakh lines of code we have, right? So now, finally, okay, so the dot class file, right? So once you, this is the Java program, right? Now, once we compile, finally we will get what? Bytecode, means dot class file. So now, the JVM will take this dot class file, will load into JVM memory. Okay. After that, what? Okay, if everything is good, the dot class file is valid, if the valid bytecode, okay, who will verify internally? Already we saw, right? Bytecode verifier. Yes, this is a valid dot class file. Then what? JVM will start execute this bytecode. So internally what it will do? Internally what it will do, guys? Okay, now see, right? Now what it will do internally, right? So here, so 10,000 lines of code we have, right? Now, this interpreter, JVM, okay? So in the JVM, there is a interpreter, right? So what is the responsibility of interpreter, guys? Interpreter, okay, read, read the first line. We have 10,000 lines of it. So each and every line, interpret, reads the line, okay? And after that, interprets, and after that, okay, execute. Right. How many steps it will take? 3 steps, guys. First of all, it will read the line. Read, and after that what? Read, interpret, and finally execute. Finally execute. So 3 steps. Okay. These 3 operations who will do? Interpreter will do. So like this. Again, right. The second line, guys. Again. The second line also again what? Okay. Read, interpret, and execute. And the third line also, read, interpret, and execute. So like that, how many times it will do? 10,000 lines of times. Okay, 10,000 times it will do. Why? In the M1 method we have 10,000 lines of code. Let's suppose in the M1 method we have 1 lakh lines of code. then 1 lakh time it will do these 3 operations. Who will do? Interpreter. First it will read that line and interpret the line and execute the line. Interpret in the sense, okay, interpret means what, guys? Okay, here interpret means what? Okay, translate. Okay, translate into, okay, machine, okay, machine code, guys, machine understandable code. Okay, machine code. Translate byte code into machine code, guys. Right? Translate byte code into whom? Machine code. Translate byte code into machine code, guys. That is what interpret. Okay. After that, once it is converted into machine code, after that it will execute, guys. So like that, line by line, it will execute. Right. So how much time it will take, guys? Okay. Right? A lot of time, because what? 10,000 lines of code we have. So now from somewhere, okay, this is the method. So from somewhere we are calling this method. Okay. So we are calling, okay, M1 method. Okay, we are calling this M1 method. First time we are calling. So when you call this M1 method, so that time, right, the program will start execute. So now interpret will interpret one by line. Read, interpret, and execute. Read, interpret, and execute. How many times it will do? 10,000 times it will do. Understand? So after that, again, we are calling this M1 method. Okay, now again, M1 method has been called, and JVM will try to execute all the lines of code. How it will execute? Again, JVM will call interpreter, and interpreter will comes into picture. An interpreter read the each and every line and interpret the line and execute the line. Like that, how many times it will do? Again, 10,000 times it will do. Understand? Again, we called M1 method, right? So again, M1 method has been called, and again, interpreter will read each and every line and interpret the line and will execute the line. So here interpret means what, guys? Translate byte code into machine code, guys. Okay, like that, it will read and interpret and execute. So like that, it will happen. So now, okay, so when you call 3 times, okay, so JVM understand. Oh, I think this M1 method is a not a one-time execution method. This is what? Repeatedly executable method. Okay, JVM will understand, right? This M1 method is not one-time executable method. Okay, this method is what? Repeatedly executable method. So we need to focus on this method. Like that, it will think, right? So in the JVM, right? So there is a hotspot JVMs, guys. Hotspot JVMs. So this hotspot concept introduced in what? JDK 1.2 version, guys. What is that? Hotspot JVM. Hotspot. Okay, hotspot JVM. This hotspot JVM, okay, this concept introduced in JDK 1.2 version, okay, introduced in JDK 1.2 version, 1.2 version, but from 1.3 hours onwards, right? But from 1.3 version onwards, every JVM is by default hotspot JVM. Hotspot JVM. Understand? So here now, so here what, guys? This method is what? Every time it is executing, right? So this is what? This is not a one-time executable method. This is what? Repeatedly executable method. Now, so here every JVM, okay, it will maintain one count, guys. Okay, it will maintain one count. So let's suppose now we are calling M1 method. Okay, we are calling first time M1 method. Now count will be what? There is a count, guys. Every JVM will maintain one count, guys, per method calls. Let's suppose the first time we are calling. initially the count is 0. Okay, now M1 method we are calling. So what is the count, guys? Now, okay, now count will become what? 1. Right? Now count will become what, guys? 1. Count will become what? 1. So again, so that these 10,000 lines, this read and interpret and execute will perform. How many times? 10,000, from 1,000 times, because we have 10,000 lines of code. Again, we are calling M1 method. Now the count will become what, guys? 2. Right? Count will become what? 2. And again, this 10,000 lines of times, okay, each and every line, these 3 steps will be performed. Read, interpret, and execute. Like that, 10,000 lines it will do. Again, we call M1 method. Now, count is what, guys? 3. Okay. So now, when the threshold reaches 3, okay, when the threshold reaches 3, okay, then JVM will think this is, okay, not single time executable method. This is, okay, every time repeatedly executable method. So that time, okay, JVM will translate, okay, will convert all the 10,000 lines of code at a time into what? Okay, machine code. Okay, so that time it will not perform read and interpret and execute, guys. Understand? Once it reaches to threshold 3, after that, if you call the same method now, okay, it won't call. Let me call now. So here M1 method again I am calling. Okay, again we are calling what? M1 method. Okay, now threshold reaches to what? 3. So after that we are calling again M1 method. Now JVM will convert, okay, all the 10,000 lines of code at a time into who? Into what? Machine code. Now JVM will execute all this machine code, guys. Understand? So instead of performing again read and translate and execute, instead of doing, okay, 10 times like that at a time, all these 10,000 lines of code will convert into whom? Machine code. Okay, the machine code will start execute. Okay, so who will do at a time? Who will convert this all the 10,000 lines of code at a time into machine code, guys? So there is a concept called JIT compiler. There is a concept called JIT compiler. This is what? Part of JVM, guys. This is part of JVM. Now JIT compiler will comes into picture. Okay, this is not, okay, one-time executable method. This is repeatedly executable method. Instead of, okay, read and interpret and execute, let me translate entire code into machine code. Then at a time we can execute. Understand? So this, due to this JIT compiler, okay, so we can say Java is high performance, right? So definitely, right, we can achieve performance, right? Instead of making each and every time read and interpret execute, instead of that, okay, if you convert whole thing into machine code and if you execute, definitely we will, okay, we will achieve what? Performance here. Okay, so due to this JIT compiler, okay, so we can say Java is what? High performance, guys. Java is what, guys? High performance. Okay, this. So okay, now, okay, so now due to this JIT compiler, okay, this JVMs what, guys? Hotspot JVMs. Understand? So we can say, okay, hotspot JVMs. These methods what, guys? Hotspot methods. Okay, so these are what? Hotspot methods, right? So due to this count, this threshold value, will be vary from, okay, JVM to JVM, guys. Okay, for few JVM, this threshold value can be 2. For few JVMs, this threshold value can be 3, guys. Okay, so understand how Java is high performance. So due to this JIT compiler, just in time. JIT means what? Just in time compiler, guys. Within just in time. Okay, just in time. JIT means just-in-time compiler. Okay, within less time, it will convert everything into machine code and it will start execute, guys. Okay, clear? So this is what high performance feature, guys. Hope you people understood what is high performance, right? Okay, so now finally we have a dynamic, guys. Okay, let me complete it. So that what is the final last feature, guys? Dynamic feature. Okay, dynamic. What is the dynamic? Okay, so now Java is dynamic, guys. So what is the Java? Why Java used to call as dynamic? Okay, now we will take one real world example. What is the real world example? So let's suppose in your house, okay, 10 people are there. Okay, so for monthly, okay, so for 10 people, let's suppose one rice bag is required. One rice bag is required, right? Per year, how many rice bags we require, guys? 12 rice bags is required. Okay, 12 rice bags is required here. So there is a two ways, guys, to purchase rice bags. Okay, per year. So let's suppose for entire year, okay, we can purchase for entire year. Okay, so how many rice bags we have? 12 rice bags, right? At a time, we can purchase these 12 rice bags, right? So like this. Hmm. And the first month, and the first day only, okay, I can purchase, okay, this entire 12 rice bags. Come on. So at the first day, in the first month, because what we are thinking, 12 rice bags is required, right? So at the very beginning, okay, the first day in the first month, we can purchase all the 12 rice bags and we keep it. That is one way. So what is the another way, guys? What is the another way? Okay, so the first month. Okay, so now I need what? One rice bag. So I called, okay, the ration shop. Okay, I called him. Hey boss, I need one rice bag. Can you please send? Okay, he sent one rice bag. Fine. Okay, the first month is completed. The second month. Okay, once rice bag is completed, again I will call. Okay, the particular ration dealer. He will send one more rice bag. Here, what we are doing based on the demand. Okay, based on the demand, we are getting the particular rice bag, right? So here what at the beginning itself, okay, we are loading all the rice bags. But here what based on the demand, when we require that time only we are getting that particular rice bag. Okay, these are two ways, right? So in the same way, we can apply the same thing into whom in the Java programming, guys. Okay, how can we, right? Now, so now so let's suppose, okay, let's suppose we have a Java class case. Okay, let me write some Java class here. The sample Java class test I have written. So in the Java class test, okay, so there is a, okay, public, right? Public static void main method. Void main method. So always Java program executes what, guys, from the main method. Okay, I know you don't know anything about because we are very beginning of the core Java concept, right? So okay, just listen, guys. Okay, so now here, here what I just I print system.out.println. Okay, here I just print welcome to okay Java world, something I printed, guys. Okay, fine. So here, okay, just I am using student class functionality here. Student, okay, s is equal to new student. I want to use student class functionality. Okay, I created student class object. At the same way, I want to use employee class functionality also. I created employee object. Employee object. Okay, just I close main method and I close test method. See here, okay, now this program I wanted to execute. Okay, at the very beginning, in the time of this statement, at the time of this statement, how many classes are loaded, guys? Only one class is loaded, that is test class. Understand? Only one class is loaded, that is test class, right? Because what? Program will execute from here only. After compilation of this test class, after compilation of this test class, okay, we will generate one byte code, right? That is dot class file, right? The dot class file to whom we have to hand over JVM, right? So JVM will start execute. So always JVM from where it will start execute, guys? By calling main method. Okay. So JVM will call this main method. From this main method, okay, class is started executing. Now, what is the first statement? Welcome to Java world. This is what console statement, system.out.println. So welcome to Java world. The statement where it will print in the console. Fine. So after that, student s is equal to new student. Here student is what? One more class, right? So when the statement encount, so by that time only the student class, okay, student related dot class file will be loaded into the JVM memory. Understand? So after that, another line. This is what? Employee. We are trying to create object for what? Employee class. Then this employee related dot class file will be loaded into the JVM memory. Understand? Will be loaded into the JVM memory. Here see, okay, based on demand. On demand only we are loading, guys. Okay, on demand only we are loading, right? This is what, guys? Dynamic feature, guys. Okay, this is what? Dynamic feature. Okay, so we are not loading very beginning, guys. We are not loading very beginning. Understand? So here, let's suppose there is an import statement, guys. Okay, how to load, how to use the particular classes. Let's suppose in this class we are using, okay, array list class. So I'm writing java dot io dot star. Io dot star means what? The array list class. What is that class, guys? Predefined class. Who supplied that class? Java people. So that class where it is available, java.io package, guys. There is a java.io package. There that particular class is available. I know we don't know anything about package and all. We will see, guys. Just listen. Okay. As of now, just listen. So there is a class array list where it is available java.io.package, guys. See, very beginning, I'm writing import statement, import java.io.star. Okay. So now people will say, hey, I imported java.io.star means what? All the classes which are there in java.io package, all the classes will be loaded. Okay, very beginning of the program, right? No, guys, it will not like that. Okay, no such class will be loaded, okay, from the java.io package, guys. Okay, if you use import statement also at very beginning, okay, so none of the class under java.io package will be loaded into the JVM memory, right? So when you use that particular class in your program, then only the particular class will be loaded into the JVM memory. Okay, this is called what, guys? Dynamic feature in Java. Okay, now let's suppose here we are using that particular class. Let's assume, right, in this statement. Okay, so let's suppose here I'm writing what? Hmm. Array list, array list. Okay, AL is equal to new array list, right? New array list. Something. Just I'm creating object of array list class object here. So now, so in this statement, after employee statement, we have which statement, guys? Array list AL is equal to new array list. Okay, when the statement is executing, so by that time, right, this array list class will be loaded into JVM memory. Until that, okay, array list class will not be loaded into JVM memory. Understand? So what is this guys? Dynamic feature on demand. Based on demand only, that particular class will be loaded into the JVM memory. So due to this, what? Okay, we can achieve performance of the program. Understand? Due to this, what? We can achieve performance of the program, guys. Okay. So in the case of Java program, all class files won't be loaded at the beginning. At runtime, if JVM required any class, then only the corresponding class file will be loaded dynamically. Okay. Right? So this is what guys, dynamic loading. Okay. What is the main advantage of this dynamic feature, guys? The program will always get latest version of .class file, and memory utilization also will be improved, right? Memory utilization also will be improved. Unnecessarily we are not loading, right? Okay, unnecessarily we are not loading any classes, right? So now, let me write those two statements, guys, here. Okay, then we can close it. I know this is a little bit lengthy video. Yeah, of course. Yeah. So here what we are seeing in detail and in depth, right? So definitely we'll see lengthy videos. Okay. Now, in the case of, tell me, in the case of, okay, Java program. In the case of Java program, right? Hmm, all the all the dot class, okay, files will not be loaded at the time of beginning, right? The time of beginning, right? So at runtime, right? At runtime, if JVM is okay, if JVM is required any class, okay, then only hmm, then only the corresponding hmm, then only the corresponding dot class file will be loaded into the memory, into the JVM memory. JVM memory. This is called dynamic loading. This is called what? Dynamic loading, guys. Okay. Now, what is the main advantage, guys? The main advantage of, okay, the main advantage is what? The main advantage is, program will always get here. Program will always get what? Latest dot class file, guys. Okay, latest version of latest version of dot class file. The main advantage, program will always get latest version of dot class file. Okay, and memory utilization also improved. Memory utilization also improved, guys. Understand? The main advantage is program will always get latest version of dot class file, and memory utilization also will improve. So how can you say the latest version of dot class file, guys, here? Let's suppose very beginning of the program. Okay, let's suppose very beginning of the program. Okay, at the first line of the program. Okay, the program will start execute one by one, right? The first execution of the lining at the first line of the program. Okay, let's suppose that student class we have. Okay, if you load the student class at very beginning of the program, right? So now into the JVM memory, what will happen? let's suppose this program has, okay, 1 lakh lines of code, right? If you load the student class very beginning of the program, right? After 50,000 lines of code execution, okay, someone changed the student class functionality, right? The student class functionality, someone changed. Where after 50,000 lines of the code execution in the same program. Now, at the 60,000 lines of code, we are using the student functionality, right? So now, in which version you will utilize here? Okay, the old version of student.class file. Why the student class file dot class file? When did you load? At the beginning, right? So by that time, okay, what is the version of student.class file? Old version. But at the line number 50,000 line, okay, 50,000 line. So by that time, someone changed, okay, the functionality of student class. Something is added in the student class. Now at 60,000 line of code, we are using the student class functionality. Understand? Right? At 60th line of code, we are using what? The student class functionality. So by that time, which dot class file you are available? The old dot class file. The new version of dot class file you will not receive here. Why? You are not loading the student class file at 60,000 lines of code, right? Where you are loading the student dot class file very at the beginning, right? So instead of at beginning on the demand, if you load on the demand, where I mean here at the 60th, okay, 60,000 line of code at that line number, I'm using, okay, I'm loading this particular student class, okay, I'm using the student class functionality. So now, when the dot class file will load at the 60,000 line of code execution, by that time only the particular dot class file will be loaded into the JVM memory. So that what always you will get the latest version of dot class file. Clear? Right. So if you load a particular dot class file on the demand dynamically when it is required. So by that time, if you load the particular dot class file, always you will get what? The latest version of dot class file. Clear? Right. So that is the meaning, guys. Okay. And the main advantage is program will always get latest version of dot class file and memory utilization also improved. Right? Memory utilization obviously will get improved, right? So here what unnecessarily we are not loading all the dot class files at the beginning, whether we are utilizing those or not, right? If you load all the dot class file very at the beginning, what will happen? Let's suppose you are not utilizing the student class functionality, or you are not utilizing this employee class functionality, or you are not utilizing this array list class functionality. Unnecessarily, we are loading this class related, all these dot class files into JVM memory, right? Unnecessarily, we are wasting memory, right? Okay. If you load very at the beginning, right? So instead that if you load based on the demand, based on requirement, then happily we can improve memory utilization. Okay. Hope you people understand. Okay. Clear everyone? Okay. So if you like, okay, please subscribe my channel. Okay. Please like it. Could you please share with your friends, guys? Okay. Thank you all. We will see next class, guys. Okay. Thank you.